coastal wetlands are extremely important to the Great Lakes themselves, even much more than we had ever realized. The coastal wetlands are sort of the last line of defense as pollutants come off the landscape and into the Great Lakes.
We do rely on them in ways that are not quite as tangible. The replenishment back to the atmosphere of the water, the production of oxygen, the productivity of wetlands has been long documented as primary in their function to us.
The coastal wetlands are the hot spots for productivity. That's basically feeding the Great Lakes ecosystem. The system itself wouldn't be able to support so much biomass or the big fish without having this productivity that the coastal wetlands are supplying.
We've lost somewhere in the neighborhood of half of Great Lakes coastal wetlands that were there historically. These systems form, these habitats form right at the coast, and that's right where, that's land that the population values incredibly.
People want to live on the lake. In general, they don't want a coastal wetland in front of their house. They want to see the water. They want to be able to get their boat in and out very easily. So we've been developing these areas for many, many years.
We sit on this just incredibly valuable resource, and they're also, incredibly important economically. The fisheries in the Great Lakes are tremendously valuable, and just a resource that's unique and that we have and that's been abused over the years, but we're in a position now to restore the lakes to sort of their full value.
There were many individuals calling for indices of biotic integrity for Great Lakes coastal wetlands, and that is a means to measure ecosystem health in coastal wetlands. So in 1998, there was the call for this. In 2000, the US EPA put out a request for proposals to form a consortium, the Great Lakes Coastal Wetlands Consortium, and it was to address this problem of how do we, one, know where the Great Lakes coastal wetlands are, and two, what kind of condition are they in? Are they improving in health? Are they degrading? We just didn't know.
Implementing this monitoring program is really built on close to 15 years worth of work, developing these monitoring tools. Scientists have come together from all around the Great Lakes Basin over these years to provide sort of the best monitoring tools possible. This project specifically, this current effort, has brought together a lot of those groups that were involved in the initial development, and we assembled a team that was that not only had a diverse set of expertise to do this project correctly, do it right, do it efficiently, but also groups from around the Great Lakes Basin that have access to these sites.
We had government agencies and provinces, both provinces and states, measuring things in coastal wetlands, but they were all measuring something different. And there was no way to put all these data together and actually analyze the entire basin. No one has come close to this geographic scale. We're across the basin and we're essentially measuring ecosystem health and sampling everything from chemistry to invertebrates to fish to plants, birds and amphibians in every single Great Lakes coastal wetland in the basin that is greater than 4 hectares in size.
So, we can provide information on what the most pristine systems look like and what the impacted systems look like.
Maumee Bay is one of those coastal wetlands that is pegged for restoration. So that's one of the sites that we call our benchmark sites that we will continuously return to and watch the trends in ecosystem health.
So today we'll set nets in 2 zones probably. and then we'll do invert reps along with the water quality. And then tomorrow we'll come back and catch our fish and finish up the sites.
So the first thing we do when we pull into a site is grab the water samples, and we want to do it without disturbing any of the water quality. So we have an extension rod, and we just pull it right from the surface, and we dump it into the carboy from the funnel with the funnel on top. And we'll do this 3 times. Jack's going to head to the front of the boat, and he's going to start taking water quality samples with the data sonde.
So back at the lab, we'll take those water samples and we'll analyze them for multiple forms of nitrogen, soluble reactive phosphorus, chloride. We'll look at the water color, and that gives us a good snapshot picture of the water quality in those wetlands. The water quality tells us about the nutrient conditions, how much nitrogen and phosphorus there is, how much chloride there is. The nutrients and the chloride run off the landscape. They give us information about the impacts in that system.
Turbidity's high for comparative to other areas, but if you look at the water, it was at 20, so that's about normal. Everything else looked pretty good. Conductivity was also a little bit high. If you had a really high conductivity, that could be indicating that there's a lot of pollutants and things coming into the system. So usually anything above 600 is going to indicate some kind of a pollutant. And so we're at 0.565, which is a little bit high.
I am right now netting for macro invertebrates. I just scrape along the bottom and try to catch stuff.
We are picking macroinvertebrates from gridded white trays. You focus on 1 square at a time, so you get an equal representation of small and large organisms, because the tendency is to pick the largest, most evident individuals from your sample. So you pick them square by square, get a good distribution of what species are present. And these were collected using a deep-frame dip net. You pick invertebrates until you either reach 150 individuals or 30 person minutes, and then go to the next replicate of 50.
And our teams go out and they scoop through the vegetation. They try to represent all the microhabitats that occur within a given vegetation type. And so they sweep through the vegetation, and then the organisms are picked and placed in a preservative, and those samples come back to the lab, and we identify each of those organisms. So if we get only very hardy invertebrates that can tolerate low dissolved oxygen and they're not sensitive to certain pollutants, if that's the only type of organism we get, we know that that's an impacted system. If we get a lot of sensitive organisms that they need very specific conditions, they can't tolerate pollutants or low dissolved oxygen as an example, that could tell us that it's a fairly healthy type of ecosystem. So when a group visits a site, it's generally for a couple of days. First day, sampling the water quality, setting the fish nets, sampling invertebrates if they have time, sampling all the covariates, looking at surrounding land uses and other impacts to the system. Then they have to return on the second day to retrieve their nets, work up the fish that they caught, identify everything. And, so a minimum of 2 days at most sites.
When you take that entire ecosystem and all the key components of the ecosystem and measure these things and then put them into terms of indices of biotic integrity, you can really get a pretty firm and confident measure of ecosystem health.
So it just went down 9 centimeters.
We're going to do the gar first.
Yeah, thanks, Carly.
I know.
This is a long-nosed gar.
Heavy. See?
They're predatory, as you can tell from their large teeth.
They like Great Lakes.
And they can breathe air. They're an air breather. You can hear them gulping air sometimes when you pull them out of the net.
That little nut.
Oh my God, there's still a
Thank
bus
you.
load? I
Yeah,
thought
dude.
you were kidding when you said
Dude.
there's 30 in it.
No, no, man.
You trapped me in here.
That's okay, right?
I go fish.
They were spawning. That's why we had so many of them. I think it's good that they're using this habitat and that they're using the coastal wetlands, but that's where they do spawn.
See all this fishing?
Coastal wetlands are great places for spawning in nursery habitats. There's protection there, there's cover from predators, and there's a lot of food. That's where the productivity is in the Great Lakes. The measures of ecosystem health really incorporate the entire fish community. We can't really look at just one or two species.
I really like doing the fishing parts where we collect from the nets, and so I've gotten to learn a lot of different fish and how to ID them and what they are and all different kinds of fun facts about them. So I think that's probably the favorite part of this project as a whole, is getting to learn more about the fish and the bugs too, but mostly the fish.
This is a channel catfish.
It's a black crappie.
The mad tom.
The yellow perch.
Bullhead.
Yellow bullhead.
The mud minnow.
That's the mud minnow.
Pumpkin seed. So this is a Blandings turtle, and these guys are state listed as species of concern. All right, hold on. Let Neil get the water depth. Hold on, Neil. He's got a snapper in his hand.
I already got
so-
water depth. Thank you.
Yeah.
Put it in his mouth.
Give him something,
Give him something to bite on.
Light it.
Common carp. They can probably get, what do you
60
think,
pounds.
60 pounds?
Yeah.
Yeah.
There
Your common carp. The way they feed right now, they're spawning, and the way they feed is they're benthivores, so they're eating invertebrates and things in the sediment. The way they get at those is sucking in a bunch of the sediment on the bottom and really stirring it up. They're rooting around with their snouts, uprooting vegetation, making the water really turbid, and so then algae and things can't grow as well. So that's how they feed. Spawning, they're right up here in the shallows. You can actually see their dorsal fins. You can be walking through a wetland in the Great Lakes and be practically tripping over common carp as they're up in the shallow water to lay their eggs. The fish aren't native to this area, so it's an impact because we've imported carp to the Great Lakes. So the north end of Lake Huron, where we're at right now, there's a lot less agriculture surrounding these areas, and so you get a lot less nutrient pollution, less runoff, and population density is much lower, and so in general the nutrient load is lower, and so that sort of changes the nature of the wetlands. There's less muck, tend to have more wetlands with sandy bottoms, and cleaner water. And that definitely leads to a different fish and invertebrate community. You get more sensitive organisms living in these wetlands. So a wetland like this, where you've got open Lake Huron water mixing in It's a nice deep site. You've got bulrushes out there at the outer edge that are in a meter of water. Really good habitat, really good nursery habitat for a lot of fish that are important recreationally and people really value. Things like yellow perch, largemouth bass, smallmouth bass will come into these wetlands and spawn, and then move out into the more open water, deeper areas where people are fishing for those fish. Oh my gosh, there's like a million fish in here. If you look around the surrounding shoreline here, the development tends to be fairly low density residential, a lot of cottages and summer homes and those sorts of things, which still certainly impact the water, but not nearly as much as the high density urban or the agriculture like we see in Saginaw Bay or Lake Erie. These wetlands up here are in really good shape. In general, these are sort of reference quality systems in most cases. The areas around the busier harbors or where there's a sewage effluent, then you definitely get the nutrient pollution and the impacts by boat traffic and those sorts of things. But in general, a lot of these embayments up in the Lake Chenot are really high quality systems that should work hard to conserve and protect. There's definitely less Phragmites up here. We're seeing a little bit of invasive Phragmites, which is really unfortunate that it's making its way up here, but nothing like we see in the more southern Lake Huron wetlands where you get the dense stands of Phragmites across the entire wet meadow. There's a native strain and an invasive strain, different haplotypes. The stems aren't as robust. It's still growing really thick, like the invasive haplotype does. Really dense monodominant stands, but the stems certainly aren't as thick. It's not as tall as what we see in Saginaw Bay. This certainly wasn't here a couple of years ago when we were doing some work out in Mismer Bay, and as tall and dense as it is, it's alarming to think that an area like this with a nice diverse wet meadow could become invaded and resemble what we see around Saginaw Bay or Lake Erie.
It's been discovered that a lot of these invasive species of plants, one of the reasons why they're so competitive and one of the reasons why the natural areas decline so quickly is that we know now that they're producing chemicals that we call allelopaths. And these allelopathic chemicals have the ability to prevent germination of seeds. They prevent and hinder the growth of other species of plants. And more importantly, we're finding out that they are toxic to the soil flora, such as the bacteria and fungi that are at the core of our food chains and our ecological webs. Even if we take out the invader, such as the Phragmites grass, which is so prevalent up here in northwest Indiana, we found out that once we take it out and remove it, that those allelopathic chemicals are remaining in the soil, preventing further germination of native species and causing damages that we can't even comprehend.
So the invasive genotype of Phragmites australis is just an incredibly aggressive plant. It grows extremely tall, taller than any of the native herbaceous Great Lakes Coastal Wetland plants. It can shade out the natives, puts up an incredible amount of biomass every season, and it completely changes the character of these systems.
We did the training session, it was probably about 3 to 4 weeks ago, and they were maybe 1.5 to 2 feet tall. And so in a matter of 3 to 4 weeks, they reached almost their mature height, somewhere around 12 to 14 feet. So the ones that are brown are actually the seed heads from last season that you're seeing there that didn't get knocked down in the winter. So the green ones are all the new growth that emerged this year. Phragmites grows very, very dense. And so it's hard for fish and invertebrates to use that area within it. And by making it such a dense monodominant stand, it really reduces the diversity of organisms that will be able to use it. Most other plants that are native don't grow nearly as dense as this. So as you can see in that lily mat, the surface of the water tend to be mostly covered with the lily pads, but you could easily walk through a lily zone, but it would be very, very hard to kind of walk through the Phragmites.
So Phragmites spreads incredibly fast for a wetland plant. It's an incredibly aggressive invasive species. At this point, the treatments they're still experimental but seem to be most effective include a combination of burning, cutting, and herbicide. It's certainly sweeping across certain areas of the Great Lakes. Saginaw Bay, for instance, from the southern, inner part of the bay northward, spreading incredibly rapidly.
You know, see almost a fish point over there. And then, so if you look around the tan dead vegetation is all last year's Phragmites stems that are still up. You can see we're looking around the entire inner bay, all the way around to, you can almost see the Bay City, and you can see it's all totally filled in. So the wet meadow, what used to be native wet meadow, is all monodominant Phragmites now.
The Phragmites invasion is a huge problem. Now the next question is, will we ever get all of it back? And the answer is probably, or at least I feel, probably not. Can we get some of it back? Yes. Farmlands impact the wetlands by contributing usually a lot of nutrients to the ecosystem, making them much more productive.
Ditches and the water control structures are designed to keep that farmland dry enough for production. And so that drainage network is designed to move water from the landscape out to rivers and get rid of it. We add a lot of fertilizer to these lands to increase food production, but some of it doesn't get used, and it runs off through rainwater, and then it ends up in the drainage ditches, and then into tributaries, and then eventually into the Great Lakes.
Excess nutrients are going to make that system very, very productive, and it's going to make that system age much, much quicker. But I think to give agriculture a break, we're incorporating better management practices. I think the farmers realize they don't want to. They never wanted to have a negative impact on the system.
So the Great Lakes coast is incredibly valuable land for industry, especially industry that either uses the water itself, for instance power plants, or industries that just need a lot of water. It makes sense for them to be located along the shoreline, as well as industries that have a shipping demand. But those industries, they take up a lot of space, and some of that space would have historically been coastal wetlands.
I think the National Lakeshore is special because we have such a wonderful complex of dunes and wetlands and many different habitats, from bogs to marshes to oak savannas, and the fact that we're located in such close proximity to industry and to many towns kind of makes us unique. We see, if the national park had not been formed here, if Indiana Dunes National Lakeshore had not been formed, much of the area probably would have been developed. So when we see the towns and the industries and whatnot, I think it helps us realize how lucky we are to still have such wonderful natural area right here.
There's a tendency to be critical of industry and agriculture as the key detriments to these wetlands and other natural areas. But these industries and other effectors, they are only operating off of our demands. And so if we need gasoline, the refineries are going to make gasoline, and they necessarily have to have some sort of effluents and toxins released from the processes. Same with the steel plants, same with agriculture.
Yeah, we see the impacts where the people are. So the people tend to be in the southern portion of the Great Lakes. As we move farther north, fewer and fewer people. And obviously you're not going to have the industry where you don't have the people to utilize it.
It comes down to thinking about these chains and thinking about everything that you do and everything that you eat having an impact. How is it impacting the individual wetlands and the rest of the environment with the most simple act of just existence? We're demanding from the industry that in the production of the things that we're asking them to make for us, we're telling them that they cannot put these things into the environment, which they're in total agreement with, but it's very difficult for them to do.
As a society, we're realizing what our water quality means to us, but we also have to realize we also need agriculture and we also need industry. So it's a matter of getting all of these players together and trying to do it better.
So the Great Lakes are, I think anyway, just now starting to become valued as truly inland seas. A rare, unique, very special habitat, and an incredibly important habitat. And that realization has really come from, people becoming educated on how important the lakes are.
And I think it's been very interesting that there is such a disconnect between the scientists, the politicians, and the public. And that when we do sit down in the same room, I think I'm often amazed at how simple it is to resolve and make everyone in that room happy, and just do things a little bit. Everybody has to do things a little bit differently, and start to realize that many things that we depend on for everyday life, these systems are actually very important to them, even though we don't see the direct link. So it's up to the scientists to get with the public and the politicians and really share information and educate everyone all the way around.
But the best thing we can do is communicate with each other, and individuals make a difference, but whole communities of people working together are what's going to make the difference. And being conscious in your daily life of the impacts that you're making down the road, not only what you buy at the store and how you use it, but thinking about what the long-term effect on the environment as a whole will be from using that product.
And so if you use the resource, you need to become educated on how can I best take care of this place that I value, that I like to visit, that I go out on my boat.
Now we have funding secured for 5 years, but we really don't plan on stopping after 5 years. We really have to keep this monitoring program going essentially indefinitely. We tend to do the restoration and not follow up on measuring how successful the restoration was. And that's critical, because we could continue to make the same mistakes over and over if we're not tracking this through time.
In the end, we can look at all the coastal wetlands across the basin and say, this is the health of them. These are highly degraded, or these are really pristine, and here's the proof, and here's why. And being able to teach other people how to do it also was a really cool opportunity that I wanted to take part in.
By removing any of the few coastal wetlands that remain, we're going in the wrong direction. We're not getting better. We're going to start moving in the other direction. We have to start restoring some of the coastal wetlands that we've already lost to turn this around.
Our plant communities and animal communities are reacting. They want to survive. You just have to look around. There's always something new to see, something that strikes your imagination.
And they're wonderful places to just explore and enjoy the variety of nature that can be found in them. So there are all kinds of great ways that they're contributing. And we just didn't recognize that. We as humans didn't recognize that for a long time, but we do now.
We're up with the sun and work till midnight or so usually, and not sleep much on these trips, but we get to be out here and it's beautiful, and get to work with good people. New students come through every summer, so you get to meet new students and sort of help them learn the techniques we're using. And it's a combination of really believing in what we do with just the enjoyment of being out here is really what makes it.
Well, I guess I've never really thought about coastal wetlands a lot before. It's kind of an underappreciated ecosystem, I think, and you don't learn a lot about them in school. And so I guess before I heard about this job, I never really thought about coastal wetlands a whole lot, but now that I'm starting to learn more about them and working in them, you realize how important they are and how cool they are to work in, and I think it's an exciting project, and I think once people start learning about the importance of wetlands, that our work's going to mean more when people understand what it means.
I'm very glad I get to do something important like working in the wetlands, because it's really crucial that we help our environment and help out the world to be a more green place, and so this is just a great way to start doing that.
There's a lot of really cool fish out there, and there's a lot of really neat bugs that we don't always take the chance to look at, and I think the loss of that diversity is the worst thing that could happen. And then something that's easier to convey to people is, the loss of recreation if we don't take action and make sure that we kind of reverse some of the changes and restore habitat and protect what is currently there.
Coastal wetlands on the Great Lakes, they're fairly rare habitat. A lot of the shoreline around the Great Lakes is not wetland. A lot of it's beach, cobbly beach, or just bedrock. But these wetland areas represent just a highly productive, highly valuable habitat. They don't take up that much space, but they're incredibly valuable in terms of the health of the Great Lakes ecosystem as a whole. And so restoring as much as we can of what's been impacted or lost, and preserving what we have is it's a strategy for ensuring a healthy Great Lakes ecosystem into the future.